I'm Will. Today I'm going to give you a talk on abstract base classes and how you can use them to solve two separate problems when making interfaces in Python. So to start, who here is familiar with the concept of an interface, either in Python or just in general? Yeah, okay, most of you, that's good. But so we're all on the same page. Interface in general is just it's a set of guarantees about a type. For example, that a certain method exists and is implemented. In Python, normally what you do is you put together an abstract class. Even if you're not using abstract base classes, the module, you put together an abstract class with some stubs methods that are the methods that need to be implemented, that the user will implement to do what they want. And you run into certain challenges when doing this. The first of these two challenges I'm going to talk about is the diamond problem. The diamond problem, I'm actually going to pull up the Wikipedia page because there's a great diagram. It's called the diamond problem because there's a diamond.
Really?
And it's a problem. And it's a problem because of the way that Python handles. Well, really, a lot of languages handle multiple inheritance, but Python, we have something that looks like this. You absolutely can do multiple inheritance. We have A, which inherits from object. We have B, which inherits from A. C, which also inherits from A. And then D, which inherits from B and C, right? That's exactly what we had in this diagram. Oh yes, the deadly diamond of death, what it's referred to. Let's look at a concrete example so we can actually see what the issue is, where issues arise with this. So here, we only have three classes. Let's say we have these two abstract classes, but they both inherit from object, of course. So there is still a diamond. Our first class is an abstract class called queryable. No, we're not actually using abstract base classes yet. We're just saying this is an abstract class. The user needs to implement this query function. We also have an init that just prints that the init has been ran, essentially. And then we have the second class called database context. All we have here is an init function, but for argument's sake, let's say we really need this to execute, right? This, even though it's just a print, let's say something important happens here. We really want it to execute. It really needs to execute. So we create our own class, the user class here, SQLite DB context, which is just a type of database, right? It's not actually doing anything with SQLite. This is just for argument's sake. And it inherits from queryable and database context. So when we create one of these, when we just assert the constructor, that thing we really needed to happen, what was it? The database context being created? Well, we call super.init here, right? So we've done that right. But who knows what's going to happen here? Are we actually going to create our database context? I know you know, Andrew.
Anyone else know?
So there's our output, if it wasn't clear from the notebook. What happened? We executed this. We did not execute this. And what's actually going on has to do with what's called the method resolution order in Python. In Python, when you call super.init, what it does is it looks for the first parent class that has the function that you're looking for, and it executes only that. And you can actually, I didn't know until recently, but you can, there's an attribute for the method resolution order. And you can see for this class in particular, the first one is always the class itself. But then you get the parent classes in the order that they are here. And because queryable happens to be in front of database context, we don't get the behavior that we want. What do you think is going to happen if I reverse these?
It's going to work.
Yeah, and actually, sorry, I did that in the cell here, so I might as well just execute this. Now we get the other constructor that we cared about. But I mean, again, this is all just an abstract example. Maybe we care about executing both. That still doesn't solve the problem. So that's the first issue you run into. You can solve this with abstract base classes. We'll get there when we get there. I'm going to discuss the other problem first. But as a spoiler, the way you solve the diamond problem here with ABC is by taking away the diamond. You don't use real inheritance. You use something called virtual inheritance. We'll go back to that in a few minutes. So the second problem, what does anyone else know or notice something that we forgot to do here?
You forgot to implement query.
Yes, it's very trivial, but not. It's very easy to forget, right? And the important method that we were talking about earlier, the query method, we didn't actually implement it. And Python will tell you that you didn't when you try and run it, right? But it would be ideal to know before the point that you run it, right? Maybe your program, especially since this is dealing with databases, maybe it does some like destructive step before the query that happens anyways because you didn't throw an exception until you tried to call the query function that doesn't exist. So this is not ideal behavior. Okay. With those two problems explained, let's talk about abstract base classes. Abstract base classes do some interesting things when you inherit from them instead of just a regular class. There's something called an abstract meta class, which the implementation of the abstract base class uses to do some registration when you create a class that inherits from it. And to get this behavior, all we have to do is change our queryable interface to inherit from abstract base class in the abstract base class module instead of object, right? And when you do that, one of the registration things you can get is a decorator called abstract method, which registers the next method in your abstract type as an abstract method. So we haven't really changed much here other than what we're inheriting from and making sure we mark the exact same method as an abstract method. I'll run that. We won't have any output. But now, when we create our SQLite DB context, and we intentionally forget to implement a query function, right? When we create the SQLite DB context, no, we're not calling query, but when we create it, it's going to give us a type error. It says, can't instantiate abstract class SQLite DB context without an implementation for query, which is quite nice. It's a step in the right direction.
Almost like a compiled language.
Yeah, it's okay. This will come back at the end because I have a really cool trick to show you that I don't think anyone else I've come across knows about. But it doesn't quite happen at module load time. For example, you can load the module as long as you don't actually instantiate one of these, you won't get the error. But it's a step in that direction. And I will show you something later that happens at module load time that we can take advantage of. So we've solved that problem, the problem of ensuring that our interface is actually implemented, right? What about the first problem we were talking about, the diamond problem? So abstract base classes introduce something called virtual inheritance. Virtual inheritance is what I was alluding to earlier when I was talking about the ABC meta class. When there's a method called register, which you can use it as a decorator for classes. And when you do that, it registers it as a virtual subclass, not a real subclass that ends up in the method resolution order, but a virtual subclass that if you ask, in fact, down here, let me assert is subclass SQLite DB context variable. This should work. And if you're really interested, we can print the MRO. And you'll see the interface queryable is no longer in the MRO. We have SQLite DB context, and then object, right? And we call the constructor that we said was important for argument's sake earlier. But we are still, notice this assert pass, we are still a subclass, I'll say in quotes, of queryable. So it's very useful for marking things as implementations of an interface class without actually using real inheritance, right? Does that sort of make sense? Question?
How does is subclass know that SQLite DB context is a subclass of queryable if it's not in the MRO?
Great question. The meta class that I talked about earlier retains a table. I'm not sure how it's implemented, whether it's just a tuple or something else, but it maintains a table of virtual subclasses. And when you call register with this decorator, the class itself is the argument. You call the register method, it puts it into that table, and then it's smart enough to override is subclass, look it up in the table, and if it's a virtual subclass, it says yes, SQLite DB context is a subclass of queryable, even though it's not in the MRO.
Okay.
Yeah. I'm a little fuzzy on some of the details. I looked at some of it's all in like native code since it's internal to the language. It's all in C, but that's more or less how it works. Okay, talk over, right? We've solved two problems. Well, not quite, because when we go back to not using the MRO and using virtual inheritance instead of real inheritance, notice we're still using virtual inheritance in the register function here. Let's forget to implement our query function. It worked. Well, it worked in the sense that it did not give us that type error anymore, which is not ideal. And the problem here is that when you stop using the MRO, you don't get the special stuff that happens on init when you inherit from when you actually like directly inherit from a abstract base class anymore. So we've created a situation where we can't solve these two problems at the same time. If you use real inheritance and the MRO, then you have the diamond problem. If you use virtual inheritance, you don't have the diamond problem anymore, but you don't get the guarantees that you want from abstract base classes. Yeah, the question that you asked earlier, Andrew, the property that it stores it in is called subclasses. It's a internal, or it's a double underscore attribute. And so I got to thinking, is there any way we can accomplish solving both of these at the same time and make some of the same sort of guarantees about interface implementation with virtual inheritance that you get with real inheritance? So one thing we can do in our interface is we can override the register function. And let me take this out and just say what really happens with register. Again, the register function in the ABC meta class was what I was talking about earlier when I said it's kind of internal to Python. What happens when you call register is it calls this, right? So if we call this directly, this is like a no-op. It's doing the same thing that would normally happen when you call this register function, right? But one thing we can do is before we actually call the abstract base meta class's register function, we can do our own checks. We can have our own assert. This is a little bit of a naive way to approach it, but what we're saying here is when we register, we're asserting that there is an attribute, just any attribute called query, in anywhere in the MRO for the subclass that we're registering. And if there isn't, then we throw our own assertion error and say the subclass does not fully implement whatever this class is, queryable. So this will work because I have a valid SQLite DB context here. But I guess the problem before more plainly stated is that you could only like force a check for this or this, but not both. Now, if I take away the query function, we should hit our assert. Assertion error class SQLite DB context does not fully implement queryable. So that's good. If we take this away, we should actually fail the is subclass check. So it guarantees both that you have a real implementation and that it's a actual, although it is a virtual subclass, that it's actually marked as a virtual subclass. Does that sort of make sense? I know it's a little bit of voodoo overriding the register function that normally you would never, you wouldn't have a reason to do that other than making your own set of checks about a type. Okay. Now, I said before, this is a little naive because we're only like, tell you what, if I comment this out and then I add a
Query :string.
Query what?
Just :string saying that.
It doesn't actually even need that because this doesn't check types like the thing I showed you before. This should work. Yeah, see that this naive approach does allow this, which is not ideal. But I do have something that we have a debatable amount of time to go into that actually validates everything properly. I call it for now universal registration checking. And what I have here, first of all, I have a helper function that takes a class, a function or attribute name, and then the types that it should have. And what it does is it actually calls get annotations from the inspect module and validates that the type annotations that of the function in your interface match. And now in queryable, and here's a little bit more sophisticated of a register function, but the only thing that's changed is this, right? Everything else is the same. We're going to grab the entire dict of this class, including the functions, right? And we're going to look for things marked as abstract methods. Grab the annotations from them, and then for each one of those, just assert that whatever is being made a virtual subclass matches. I'm going to run this. Hope I didn't connect something up there. Yes, no, so this works. Now, what if I change the interface of this to make it incorrect? We get that same assertion error. I could probably print more debug info about what exactly doesn't match, but we get SQLite DB context does not fully implement queryable. And thus, you can actually get stronger type checking than Python offers with abstract base classes out of the box. With this, it is a little hard to wrap your head around. Andrew helped me with it, but it's not very complicated. It's less than 10 lines of code really, and you get guaranteed type correctness and implementation completeness for your interfaces. Yeah, that's all I have. Are there any questions about that? Hugh?
Is there a particular programming problem or circumstance that led you to this, or is this just just a curiosity that you're resolving?
Not to, did you come in the middle? I forget if you're here right at the start of the talk.
Probably not. Oh, well, no, I was here for your talk.
Oh, yeah, okay. Well, so the problem here is that we're trying to solve the problem of guaranteeing that your interface is implemented, and we're trying to solve the diamond problem where
I got that part.
Yeah.
I'm just saying, have you ever encountered this in something or other you were actually doing, where you had a multiple inheritance problem?
I'm going to say in Python, no. No. In other languages, yes. I stumbled across the fact that you can't solve both of these at the same time when I was messing with abstract base classes, because I already knew I wanted to give a talk over it.
Mm-hmm.
And I vaguely knew you could solve. I vaguely knew what abstract base classes did because I had seen them before, but when I got to messing with them, it kind of astounded me that you couldn't use both of the most important features of an abstract base class at the same time. Yeah. Max?
Yeah, so the point that you make about, and I guess this is a beginning thing. So I like the way that you kind of like introed into this. I remember the first time I ever took a computer science class and like learned about interfaces, I believe in the context of like Java, I think I was originally told to think of interfaces as like a contract. But I think the way they put as guarantees like that aligns really well. Regarding the initial example where you have inheritance from two different subclasses and only one runs in it. So I guess a question I have about that is, if I were encountering this problem, what I would do is I would just do, instead of doing super init, you just do queryable, like essentially you reference each class individually and then call inits there. And I could see like, okay, that would solve the problem of, capturing the initialization protocol for both of the parent classes. But you don't get the same outcomes regarding guarantees about functions and whatnot and type safety. Is there a reason why it'd be bad to do that, to like have the two parent classes and initialize them separately?
No. In fact, if that's the only problem you're trying to solve, that is exactly what I would recommend doing. The virtual subclasses that abstract base class provides, actually, notice that we never actually got around to executing both the init function of our interface and the init function of our database context at the same time. That is something you can absolutely do. You would probably just execute both init functions like you're saying. But what virtual subclasses do is sort of force us to admit what the actual most important parent class of our class is and only use that one. Remember, I think I may have said it before, but it's important to state that here we solved the diamond problem by taking away the diamond, and that's just a consequence of us using virtual inheritance. That's not necessarily what abstract base classes do, because if you keep the same hierarchy and just switch to abstract base classes, you have the same problem. You still have a diamond. So if you have, say, two different parent classes from two different modules and you need both of the init functions to execute, just execute them, just name them explicitly. And I think what you were saying to do, but just so everyone else is clear, is instead of just calling super, can I just name it by class? I think I can.
I think you can.
Yeah. And actually, considering it's an init function, you really want to run it with self. This is something that I was being lazy about in the slides. Yeah. So that solves our problem. But again, well, in fact, I haven't implemented query here. It doesn't give us any sort of warning that query hasn't been implemented. So if you're designing, if you're the user, I would just do this, and this is something I'm going to be using for the plugin interface in Pygit Web. If you're designing an API and you don't want people to be able to like partially implement your interface and maybe subtly mess something up for themselves and cause themselves a headache because they implemented most of what they needed, but they forgot an important function and it's just stubbed, then you should provide abstract-based classes, which they should virtually inherit from. Yeah. Yeah.
In the circumstance that I wanted an inheritance chain to have a default implementation, I would make it so that query, did a whole bunch of stuff and then actually return something so that in the circumstance that the user didn't implement, they would get like the default implementation. And in the case that I wanted query to be virtual or abstract, pure, and not callable, I would make it so that query had a single line of code which said, raise not implemented error.
Like this, yeah.
Yeah.
I forget if that's a real exception name, but you're absolutely
No,
right.
it is.
You probably have to import it though, right? Is it in the default namespace?
No, it's in the library.
Well, that's a good point, and that's a very common way to do this without abstract-based classes. But again, you only raise this when the user attempts to call query, or when you attempt to call
Sure,
query.
it's not a
on
compile time error.
Yeah, it's not the trick that I've come up with. It's not. I mean, there's no, unless you're writing embedded Python. There's no compilation really. But this is a module load time error. The assert actually happens when you call the decorator function. So by registering your class, you're implicitly like forcing a set of checks that I've come up with. So yeah. Any other questions? If not, I'll hand it over to the next presenter. Thank you very much.